Aló, aló. Wanti nyata kan? Anyata.
Hello everyone. Can we start off with the meeting? Is everyone ready? If you're ready, please type an emoji or do something that you can show that you're ready. Okay. So let's start with the meeting. I'm Everlyne Mwangi and I'm going to take you to in the beginners level. So let me share my screen. Are you guys able to see my screen?
Yes, your screen is visible.
Okay, thank you so much. So let's begin. So today we are going to talk about building and deploying scaling application with Docker and Kubernetes. So what is what is a container? Seems like people are joining.
Just continue presenting. I'll do the letting in of the guys.
Okay, okay. So what is containerization? This is a lightweight portable way to package and deploy application. This ensures consistency across different environments. So different environments, this is like the cloud, either you're deploying your application either in the cloud or local, or maybe you're using hybrid method. So about containerization is it is essential for microservices and modern cloud native deployment. We are going to see more on this later on. So what is orchestration? This automates the deployment, scaling, and management of containerized application across the cluster of machines. So how does containerization work? So the first step is building. You can either build a Docker file. This is by building an image by using this Docker build my app, then by running the image in a container. So remember, it is essential to run an image in a container so that it can work effectively. Number two is deploying. So you can either deploy locally or using Kubernetes. So by deploying locally, you're supposed to install WLS. This is Windows Linux subsystem. This is very essential if you're using Docker. Then the second step for running locally, you're supposed to install Desktop for Windows. So this is specifically for Windows. There are some for Mac OS or Linux. And in the setting of Docker Desktop, you can enable AWS integration, and then you can deploy your image in the container. Or we have said that you can use Kubernetes. So this this you can use it to manage deployment. As you know, Kubernetes has different type of deployment unit. There is a pod, which is the smallest deployable unit, and it manages container replicas and updates itself according to the adjustment that you have made. So what are the services? The services expose the container to the network that is supposed to be at. So number three is scaling. You can use Kubernetes to automatically adjust container instances. So for example, you can use horizontal pod autoscaler. This is to adjust a container count based on their load. Like we've said that pod is the smallest deployable unit in Kubernetes. So this is an example of a code that you can write so that you can scale your deployment level. So you'll say kubectl scale deployment my app. You can go to replicate it, let's say to 5. So let's talk more about container orchestration tools. So there is a couple of them. So for example, there is Docker Compose, Apache Mescos, there is Nobad, Kubernetes, and even Docker Swarm. So modern software stack typically contains over 1,000 of individual containers. Managing all these containers is known as container orchestration, and several container orchestration tools exist, like the one like Docker, the one which are there. So Kubernetes is estimated with a market share of well above 95%. So let's see how Kubernetes works in orchestration. It solves the typical challenges of container orchestration, that is scheduling and networking. This is where to deploy a container and how to connect them, and also how to attach storage to a container. As you can see, to do that, Kubernetes interact with container engines, and those container engines are the Docker. So you can see here in the flowchart, you can see Kubernetes is the one that is interacting with the container engines, which are the Docker. So let's see what Docker attached to it. So we can see in the traditional architecture, which are called the monolith, has single application we typically run independently from other applications, and it is hard to maintain and to update. And this is where the modern architecture is going to use the container by constructing independent building blocks, that is from microservices, which can be maintained and updated independently. So here is the couple of commands that are used in Docker for starting a container, even listing, stopping a container, or even listing it. So, for example, you can run a Docker PS. This PS is going to list the number of images that you have, and it's going to give you the container ID, the date you created, and the status and the name. So if you want to create a container name, you have to base it in the image. So you can see there is Docker run name, then you're going to give the name according the name that you want, then you're going to refer to the image that you have created or you have pulled. So you can see here we have called the container name is DP pipeline v1 and the image name is Postgres. And when you run again Docker PS, it's going to show you that it is created, and even the ports that is there. So if you want to stop the Docker, you're going to run container name, that is the DP pipeline v2, and it's going to, when you run that, it's going to stop the container. So if you want to run, let's say for example, you call your container hello world. If you run the container that is called hello world, it's going to give you the necessary document that is there. So for example, you can see that it's saying hello Docker. This is generating this message from and it took the following step by getting the Docker client and contacted the Docker daemon, then created a new container from the hello world image. Then it is streamed the output to the Docker client, which was sent to the terminal, which we are seeing right now. So what are the ways of building Docker image? You can see number one is by using Docker file. A Docker file is a text file that contains a set of instructions for building an image. So we are going to see more on an example that is on the next slide. Then number two is using Docker commit. Docker commit is when you're going to create a container from an existing image, making changes inside the running container and saving the container state as a new image. And remember that using Docker commit, you're going to use the bash, like the terminal, and this is going to be a manual way. Number three is by using Docker compose. This allows defining multi-container applications in a Docker compose YAML file. This handles dependency, networking, and scaling. This is when you are using like you want to put different application in one file. Instead of using a Docker file which contains one image, you can use Docker compose. So number four is by using Docker build X. This is for building images for multiple CPU architectures. Let's say like you want your computer is running on Windows x86, you can build an image that is going to allow you to run an ARM architecture in your Windows computer. So number three is by using CI.
Hey, sorry, you're muted. Hi, sorry, you're muted.
Njeri, if you're talking on mute. You've lost you in a few.
Hello, we have lost your voice.
Njeri. Hello, Jerry. Hello. Hello, Jerry. Jerry.
So can you hear me now?
Jerry, I think the attendees have lost you in a couple of meetings a few minutes ago.
Okay, let me share my screen there. So I was here in Kubical. This is a command line tool to wait a minute. Yeah. So I was here in Kubical. This is a command line tool to interact with Kubernetes, and it comes with many commands and options, which read your manifest and send them to Kubernetes via its API, and it will compute what to do to achieve the state that you want. And this is an example that you can use to deploy your app. So you're going to say kubicle, kubecall apply
Excuse me, Jerry.
fast manifest.yaml, and it's going to deploy your app the way you have stated it in the YAML file. So,
Excuse me,
what is the
Jerry.
difference between container and virtual machines? A virtual machine is a software-based simulation of a physical
Jerry.
computer that runs an
Hi,
operating
Jerry.
system and application just like a physical machine. And a
Excuse
container is a lightweight standalone and executable unit that includes an application and its dependency, just like libraries, binaries, and configuration files, so you can run it consistently across different environments. So the differences between virtual machine and container is that virtual machine has its own OS, but container has shares the host of the OS kernel, and this is very essential as virtual machines. The startup is very slow as it takes minutes, and containers is fast according to the network that you have. The resources for virtual machine is very high due to a full OS, and container is very is lightweight, so it runs at a low resource use. And the use case is that virtual machine runs different from different OS type, but container deploys microservices and cloud apps. So DevOps and continuous integration and continuous development. These we can automate builds using GitHub Actions and Jenkins. So this is an example that you can use. So you can build and push the Docker app into you can build and push the Docker image, then deploy it with Kubernetes, YAML with the help of GitHub and GitHub Action and Jenkins. So what is the best practices for this is you use minimal base image for security, because security is essential for the containers. Set resource limit to avoid overconsumption of the resources, and use Kubernetes readiness and liveness probes. This is like you use it for deployment as it is easy to scale. And remember that Docker does not run natively on Windows and Mac OS because they do not have a Linux kernel. Instead, on Windows, Docker uses Windows Subsystem for Linux or Hyper-VM, and on Mac OS, Docker runs inside a lightweight Linux virtual machine using HyperKit. So this means that Docker cannot run into Windows. You must have a Linux kernel that is WSL or HyperKit. So in conclusion is that Docker simplifies containerization, Kubernetes automates deployment and scaling, um, and start with Docker locally and scale with Kubernetes as it is very easy to deploy. So we have come to the end of the presentation. I'm looking forward to your question. Sure, sure. Let me share it.
Hi everyone. I hope you've enjoyed the session in the Jerry.
Do you guys have
The,
any questions?
if you've got any question at this moment, you can share on the chat or unmute. Jerry, oh, can you hear me? Hello, Jerry. Jerry, confirm that you can hear us. There's a question from the chat. Somebody is having a concern that if they could be having a practical, you could have a practical session to deploy Kubernetes.
Um, for the prac- for the practical session, I haven't prepared that. I thought maybe we could present so that you can know about the Docker and Kubernetes. Maybe another time. I wasn't ready for a practical session. And does anyone know how I can share the slides? I don't know how to share them. Yeah, maybe for practicals, you can use Google Meet. Oh, it seems that you have to use Teams.
So I don't know. Hi everyone. So I don't know where Juma is. So I think Evelyn, you can share the link, and then as it has been said, you can share on the YouTube channel and also on all the community platforms so that people can be able to access it. And then yeah, thank you for availing your time and for taking us through the session. I think if there aren't any questions, we can end it here. Yeah. So, unless there is anyone with a question. So yeah, for the YouTube link, it's on our YouTube page, and then under the description, that is where I usually add the link to the slides. Yeah, so unless there is anyone with a question, thank you guys for joining, for being active on the chat, asking questions, and also Evelyn for taking us through the session. Yeah, so feel free to drop off.